this lesson, we're going to talk about perpendicular lines. Students will use perpendicular line theorems to solve problems, like solve for missing angles. And you will also be constructing perpendicular lines. So we're going to start right off with 3 perpendicular line theorems. The first one states if 2 lines are perpendicular, then they intersect to form 4 right angles. So that looks like this. I have intersecting lines. I have line M and N, and I can say, and then I have angles A, B, C, and D. And I can say if M is perpendicular to N, then angle A, angle B, angle C, and angle D are right angles. We use this quite a bit in our proofs, and the line that we use, the way we write it, is this. Perpendicular, we use the symbol, the upside down T, perpendicular lines form right angles. So that's the first perpendicular line theorem. Perpendicular lines form right angles. The second theorem states if 2 lines in a plane are perpendicular to the same line, then they are parallel to each other. So in a plane means we don't have any skew lines. We don't have any lines sticking out of the surface. It's all on the flat surface. So let's draw this. If 2 lines in a plane are perpendicular to the same line, so here's the line. That'll be line P. And I'll have line M and N again. So here's M, perpendicular, N, perpendicular. That means if M is perpendicular to P and N is perpendicular to P, then M is parallel to N. Okay, the third theorem that we're going to talk about today, if a transversal is perpendicular to one of a pair of parallel lines, then it is perpendicular to the other. So that's kind of the opposite of what we just said, okay, or the converse. So I have a pair of parallel lines. This time I'm starting with parallel lines. And let's say this is X and this is Y. So I know if I'm given X is parallel to Y, and I have a transversal, let's call that transversal P. If it's perpendicular to one of them, then it's going to be perpendicular to the other. Okay, so to write that, if I'm given parallel lines, if P is perpendicular to X, then P is also perpendicular to Y. So those are our 3 theorems, and we are going to prove the second one. I'm going to do a proof so you get an idea of how these things work. Okay, I take that back. We're going to prove that third theorem. I was thinking it was the second one, but we're actually going to do the third one. So here's what we're given. We're given that X is parallel to Y and that M is perpendicular to X. And what we want to prove is the fact that M is also going to be perpendicular to Y. So we start off with our given. You just copy down X is parallel to Y, M is perpendicular to X, and that's given. Then what I'm going to do, I'm going to label some of these angles. You are free to, you can label angles anything you want. I'm going to talk about angle A and angle B. And remember, we already know, we're given that these guys are parallel, so we can use our corresponding angle theorems, which we'll use that in a minute, okay? So here, from the given, from the perpendicular lines, I can say the measure of angle A is 90 degrees, okay? And the reason I can say that is perpendicular lines form right angles. And then I can say right angles are 90 degrees. Okay, so I did like 2 reasons in one step, and that's okay to do. Okay, perpendicular lines form right angles are 90 degrees by definition. All right, then we're going to use the fact that these two are corresponding angles in parallel lines, and we know they are equal to each other. So I know that the measure of angle A is equal to the measure of angle B, because corresponding angles are equal in measure or congruent. I'll say equal in measure since I'm using the equal sign. Okay, and again, I don't have to write the entire thing out. I don't have to say if parallel lines are cut by a transversal, then you just say corresponding angles are equal in measure, because we're given the fact that they're parallel lines. Okay, so I have the measure of angle A is 90, and the measure of angle A is equal to measure of angle B. Therefore, by substitution, I can say the measure of angle B is equal to 90. So there's my substitution step. Okay, and then because right angles, by definition of the right angles, I can say angle B is a right angle. Definition, DEF, of right angles. Finally, by definition of the perpendicular lines, I can say that M is perpendicular to Y. Definition of perpendicular lines, DEF of perpendicular lines. And that's how you prove, it's one way to prove that if a line is perpendicular to one of the parallel lines, it has to be perpendicular to the other. Okay, so we're going to work a typical example of what you're going to have to do in your homework. I'm given 2 lines, or I'm given four lines, R, S, P, and this is Q. And you see that there are 3 right angle symbols in there. So my first question is P parallel to Q? Okay. Well, let's see here. So if I look at that, is P parallel to Q? Well, what you see is that with P and Q, we have a transversal here. And this transversal is perpendicular to both of them. So yes, P is, so yes, because the transversal line S is perpendicular to both P and Q. Okay, I believe that was our second theorem. All right. The second question, is P perpendicular to R? All right, well, let's look at that. We now know that P and Q are parallel, so we have to build from the first answer. P and Q are parallel. So our third theorem says if a transversal is perpendicular to one of the parallel lines, it has to be perpendicular to the other. So that answer is also yes. Okay. Yes. Because P is parallel to Q and R is perpendicular to Q, so P has to be perpendicular to R as well. Okay, so that's the type of question you're going to have to do in your homework. And the next part is constructing a perpendicular bisector, so we can construct right angles and perpendicular lines.